Hey everyone, today we're going to be talking about absolute value inequalities. So an absolute value inequality is really just an inequality that involves an absolute value. In this video, the only algebraic expressions that will appear inside absolute value bars are linear ones. To solve these, we go over two main types. In the first type, we have the absolute value of ax plus b is less than or equal to c, or absolute value of ax plus b is strictly less than c, where c is assumed to be some non-negative number. We know that has to be the case because absolute values can only return positive numbers or the number 0. They can't return negatives. The way we solve the first inequality is take ax plus b, drop the absolute value bars, and then place it in between negative c and positive c, like so. So to solve absolute value of ax plus b is less than or equal to c, we need to solve the inequality negative c less than or equal to ax plus b less than or equal to c. When dealing with a strict inequality, we get the exact same setup, except instead of less than or equal to signs, we have strictly less than signs. So really the deal with these types is that I have my absolute value being smaller than the number that is given, that number being c. Let's look at a few examples. We'll first solve absolute value of x is less than or equal to 4. The setup is ready to go because I have all my absolute value stuff on one side and all my numbers on the other side. Since x is less than or equal to 4, we have a type 1 inequality, so we can set up the inequality negative 4 less than or equal to x less than or equal to 4. When we plot this on the number line, it looks like this, and then we simply write our solution in interval notation. So our solution set is the closed interval from negative 4 to 4. In our next example, we'll solve absolute value of 2x minus 1 minus 2 is less than 0. We need to manipulate some stuff before we get started. The first thing we'll do is add 0 to both sides to get absolute value of 2x minus 1 is less than 2. Now that I've got my absolute value on one side and my numbers on another side, I can go ahead and proceed. This is still a type 1 problem, so I'll set up the inequality negative 2 less than 2x minus 1 less than 2. Inequalities that have 3 components work the same way as equalities or inequalities with 2 components. The idea is that if I add or subtract, multiply, or divide, I do it to all 3 parts. So I need to isolate the x variable, which means that I'm going to add 1 to the middle term and then add 1 to the left and right terms. And this gives me the revised inequality, negative 1 less than 2x less than 3. Next, I'll divide all parts by 2 to give me negative 1/2 is less than x is less than 3/2. Putting this on the number line gives me open circles over my endpoints because I have a strict inequality. Therefore, I get the interval negative 1/2 to 3/2 as my solution set. Now we can go ahead and discuss the second type of absolute value inequality. The second type covers what to do when my absolute value is greater than the number given. So if absolute value of ax plus b is greater than or equal to c, I have 2 equations to solve. The first is ax plus b is going to be less than or equal to the negative version of c, and the second is going to be ax plus b is greater than or equal to c. So in either case, I drop the absolute value bars and then I relate ax plus b to the appropriate positive or negative version of c, just like this. And it should be no surprise that if I have a strict inequality, I get the exact same setup. So I solve the same kinds of inequalities, I just replace weak inequalities with strict inequalities, like so. Let's run through some examples. Solve 2 times the absolute value of 3 minus x plus 12 is greater than 24. Just like before, I want my absolute value stuff on one side and the rest of my numbers on the other side. So I'll subtract 12 from both sides, and then I'll divide both sides by 2 to get the revised inequality absolute value of 3 minus x is greater than or equal to 6. To set up my first equation, I drop the absolute value bars and I set 3 minus x less than or equal to negative 6. As I try to solve this inequality, I find that x is greater than or equal to positive 9. To set up my second equation, I again drop the absolute value bars and set 3 minus x greater than or equal to 6. And I solve this inequality and I get that x is less than or equal to negative 3. Now I can put this information on a number line so I can read off my solution set, which will turn out to be negative infinity to negative 3 including, union, with 9 to infinity including 9. And we're done. For our next example, we'll solve 3 times the absolute value of x plus 2 is greater than or equal to 3. First thing I'll do is divide both sides by 3 to get the revised inequality absolute value of x plus 2 is greater than or equal to 1. I'll set up my first equation by dropping the absolute value of ours to give me x plus 2 is less than or equal to negative 1, which gives me x is less than or equal to negative 3. And then in my second equation, I have x plus 2 is greater than or equal to positive 1, which gives me x is greater than or equal to negative 1. Just like before, to help me read off my solution, I'll plot this information on the number line to give me the solution set of the interval negative infinity to negative 3, closed at 3, unioned with the interval from negative 1 to infinity, closed at negative 1.